So today our topic of discussion is basically atomic structure. So an atom, what is an atom? So an atom is the smallest particle of an element that can be seen with electron microscope and that cannot be seen with naked eye. So this is basically the structure of an atom. Okay, this is structure of an atom. Okay, so here basically neutrons and protons are present. This is nucleus, which is basically the center of an atom. Okay, so sorry, it's nucleus. So it's basically the center of an atom where neutrons and protons are present. Okay. So these neutron, they basically carries no charge. Okay. They are neutral. And the protons, which are also present in the nucleus, that carries positive charge. S- in the surrounding of the nucleus, the electron basically revolve in these shells. So electron revolve in these shells. Okay. They are basically called as electronic shells in which electron revolve around the nucleus. Okay. So in first shell, basically, you can say that two electrons two electrons can be filled in the first shell, and in the next shell you can say eight electrons further they would revolve around the nucleus in their electronic shells. Okay, so they are basically called as electronic shells. And the charge on electron is basically negative is basically negative. Okay. And remember one thing, an atom is basically neutral. And why they are neutral. So why they are neutral? They are neutral because number of protons which are positively charged and number of electrons which are negatively charged, they are basically equal in number. They are equal in number and they are oppositely charged. For example, if there will be two protons, then there will be uh, two electron as well, and they are basically oppositely charged. Okay, so they would cancel out each other. So atom becomes in fact electrically neutral. So it becomes basically electrically neutral. They are not charged. Okay. So they are basically electrically neutral. And if they ask you the reason regarding it, so the reason is that number of protons and number of electrons are equal and oppositely charged. So they would cancel out each other. So that cause become the reason for atom to be electrically neutral. Okay, so let's move further towards proton number and atomic number. First of all, proton number and atomic number are both same. Proton number and atomic number, they both are same. Are same. Okay. So what is basically atomic number, proton number? So the number of protons present in an atom, number of protons present in an atom is called atomic number or proton. Atomic number or proton. Okay. So the thing that we have already discussed before as well, as we know, atom is electrically neutral. So atom is electrically neutral, neutral. So we know one thing here, that proton number is equal to electron always. If an atom is in neutral state, if it is not charged, okay, either it has not gained electron or lost electron. So in that condition, number of protons and number of electron would also be same. So in fact, number of electron becomes also equal to atomic number. Okay. So now, if there is an element which is beryllium 2 4, remember the one in smaller quantity, the number in smaller quantity always represent, in smaller quantity always represent, represent, always represent atomic number, atomic number. So here we know that atomic number is 2. So in fact, proton is also 2. Number of proton is 2. And we know for neutral atom, uh, electron, that is also equal to the number of protons. So here electron will also be 2. So we have learned this thing, that the number in smaller quantity, that is always known to be as atomic number, which is equal to the number of protons and also equal to the number of electrons. Okay, so let's move further and let's learn about atomic mass, and you can also call it as nucleon number. So total number of protons, total number of protons and neutrons is called as nucleon number, is called nucleon number. Okay. So we can now take the example of like sodium. Sodium, it is 11, 23. First of all, we know the one in the smaller quantity that represents proton. Proton here is equal to 11. We know electrons are also equal to number of protons, that is also 11. Here, number of neutrons plus protons, because we have learned this thing that the number in greater quantity, that would always represent atomic mass. And we have also learned this thing, that number of protons and neutrons, that is equal to its atomic mass or nucleon number. So number of protons and neutrons, that represents atomic mass, which is 23 here. We know that proton number is 11, so it becomes 23, and n is equal to 23 minus 11, and that would become 12. Okay. So in this way, we will be able to find neutrons and protons. Just remember this thing, that total number of neutrons and protons, they basically represents atomic mass. Okay. Let's take one more example. So what we mean by isotopes? Isotopes are atom of an element having same atomic number but different mass number. But different mass number. What we mean by this thing, that isotopes have same number of protons and neutrons, or protons and electrons. They have same number of protons and electrons, but different number of neutrons. But different number of neutrons. So this is basically an important thing that we must need to memorize, that they have same number of protons and same number of electrons, but different number of neutrons. Like we can see here, this is basically an isotope of hydrogen. This is hydrogen 1, in which it has 1 proton, 1 electron, and 0 neutrons. Here again, it has 1 electron and 1 proton, but different number of neutrons. Okay, you can see that they have same number of protons, same number of electrons, same number of protons, same number of electrons. But as you can see that hydrogen 3 has mm, 2 neutrons present in it. So it basically fulfills the definition that isotopes would be having same number of protons and electrons, but different number of neutrons. So let's move further towards uh, chlorine 35. There are two isotopes of chlorine. One is chlorine 35, and we know 17, and here chlorine 37, and it's 17. We know that number of protons here are basically 17. Number of electrons here are also 17, as their atomic number is 17. So number of neutrons is 35 minus 17, and that would become 18. So proton here is 17, electron here is 17, and neutrons would be 37 minus 17, and that would become 20. So as you can see, again, it fulfills the definition that it would be having same number of protons, same number of electrons, but different number of neutrons. Okay, so let's move further and let's discuss about some of the important things that are related to isotopes that are often asked in the exams as well. Isotopes, they have same number of protons and electrons. So because of that, they would be having same chemical properties, as chemical properties are dependent on as same chemical properties. Why they have same chemical properties? The question arises is that they have same chemical properties as basically electrons electrons are responsible for a chemical reaction. For a chemical reaction, so as we know that isotopes would be having same number of electrons, so they have same number of electrons present in the outermost shell as well. So they would be having same number of valence electron. Valence electron means the electrons which are present in the outermost shell of an atom. Okay. What is basically the example which we can associate with it? That chlorine 35 and chlorine 37 and chlorine 37 both react with sodium, okay, to form NaCl. Okay. So we have to remember this thing, that this question can be arise in the paper, that why isotopes are having same chemical properties. Same chemical properties. So answer lies in that because they have same number of valence electrons, or you can even answer it that they would be having same number of electrons. Okay, so both would be correct. Now, another important thing, that we know that isotopes have different number of neutrons, or even you can say atomic mass. Atomic mass, as we know that there is hydrogen one isotope like this, and there is hydrogen another isotope which is like this. So as you can see that they would be having same atomic number but different mass number, because they would be having different number of neutrons. And now important thing here is that uh, isotopes would be having different physical properties, different physical properties. And reason behind is that physical properties are like, you can say, density or boiling point. Why they have different physical properties? Because physical properties are related with mass. So this becomes quite evident from us that due to having different masses, isotopes would be having different physical properties. Okay. And what is example for that? Like for example, hydrogen 2. Hydrogen 2 has higher boiling point and density as compared to hydrogen 1, as compared to hydrogen 1. Okay. So the important thing for us to memorize here is that isotopes would be having different physical properties. Why? Because they have different mass. Because they have different mass. Okay, they have different number of neutrons, or they would be having different atomic mass. Okay, so this is basically the answer which is associated with this question. Okay. So let's move further and let's discuss here that how electrons are arranged in an atom. How electrons are arranged in an atom. So electrons, as we have discussed, that electrons basically revolves around the nucleus. Okay. So like for example, this is nucleus. So electrons basically revolve around the nucleus. Okay. So these are electronic shells in which electrons are revolved. So these are basically electronic shells. Now, remember one thing, the electronic shell, which is further from the nucleus, which is farthest from the nucleus, would be having highest energy, would be having highest energy as it is far from the nucleus, as it is far from the nucleus, as there is force of attraction between between nucleus and electron. So the one which is present near to the nucleus, that would be having lower energy. Why lower energy? Because they would be having more force of attraction between nucleus and electron, and that force of attraction is basically called as electrostatic force of attraction. Okay, force of attraction. So it would be having the lowest energy, which is closest to the nucleus, as it would be having more electrostatic force of attraction. It would be pulled towards nucleus with more force, as the electrons which are present in the furthest electronic shell, they would be having highest energy. Why? Because of lowest electrostatic force of attraction. So how many electrons can be accommodated in different shell? First of all, there is a formula in order to find out the number of electrons present in a particular shell, that is 2n square, where n represents the number of shell. Like for example, if n is equal to 1, then number of electron would be equal to 2 1 square, and that would be 2. If it is n is equal to 2, then formula would become 2 2 square, and that would become 8. N is equal to 3, and then it would become 2 3 square is equal to 18. But however, the third shell in the elements that we are going to discuss in the O levels exam, that would also accommodate maximum of 8 electrons. This we need to memorize. It will also accommodate maximum of 8 electrons. We are considered with the elements having atomic number from 1 to 8 20, with 1 to 20. So we are considered with the electronic configuration of atomic number from 1 to 20. So we just need to memorize this thing, that third shell can also accommodate maximum of 8 electrons. And the reason of this, we are going to study it in A levels. Okay. So let's move further and let's discuss about the electronic configurations. Electronic configurations. Configuration. Okay. So if it's magnesium 12 24. We know that number of electrons in magnesium is 12. Its electronic configuration would become 2. That 2 electrons will be present in the first shell, and second shell can accommodate maximum of 8 electrons, and third shell will accommodate maximum of, like here, 2 electrons, because just 2 electrons are remaining. This is basically called as duplet, and this electronic shell is basically called as octet. Okay, so let's take one more example, which is sodium 1123, and that is first shell can accommodate maximum of 8 electrons, second can accommodate 8, and third one can accommodate maximum of 1 electron. So the last topic of this chapter is basically valence electrons. What are valence electrons? So valence electron, the electrons present in the outermost shell of an atom is called valence electrons. It's called valence electrons. Okay, so we know, like for example, if it is sodium 1123, we know electrons are 11, first shell 2, second shell 8, and the last shell can accommodate 1 electron. So how many valence electron will be present in sodium? That is 1. Okay, so in this way you will be able to find out the number of valence electrons. Okay, so this is all about this video. Thank you so much for watching. Please like and subscribe my channel. Thank you so much. Allah Hafiz.